All right, in this video, we're going to talk about how to solve some of these questions on the chapter 2 review. So the first one we got here, number 12, the sum of three consecutive integers is 582. What are the three integers? Well, the word integer refers to positive, negative numbers and the number 0, but not numbers that are fractions. So essentially, we've got three non-fractional numbers, consecutive, which means they are right in a row, and their sum, which again points to addition, totals 582. So this is kind of the information I have going into the problem. Well, first things first, let's think about consecutive integers. What would be some examples? 3, 4, 5, 29, 30, 31. -1, 0, 1, -14, -13, -12. All of those are consecutive integers. What we are told is that some group of those numbers in a row will add together to give me 582. So let's make this into more of an equation. We know the total is 582, and we know that if I add those three numbers together, that are next to each other, I will get 582. That's what the sum of the three consecutive integers being 582 means. Well, we give them variables because we don't know what they are. And at this point, we're kind of stuck. We don't know how to solve the problem at this point because we have three variables. And no matter how I move them around, I'm never going to be able to say x equals this number, y equals that number. We need to rewrite the equation so that we only have one variable. This is where the word consecutive becomes very key. What do I know about consecutive numbers? Well, we know the answer could it be, say, 3, 7, and 12, not just because they don't add to 582, but because those numbers aren't in a row. So let's say, for example, we knew that x needed to be 3. Well, then we would know y was 4 and z was 5. Another way of thinking about that is what? If x is our smallest number, then y has to be 1 more than x. So I can rewrite y as x plus 1. Why? Because these are not just three integers adding to 582. There'd be a bunch of different options there. It's consecutive integers. So y has to be 1 more than x. Similarly, z can be rewritten as x plus 2. Because what? If they're consecutive numbers and x is the smallest, then z would have to be 2 more than x. So what you go, cool, we rewrote this. How does this help me? Now I have an equation I can solve because I only have one variable. So let's combine the like terms. I have three x's here, which can combine to be 3x. And we know 1 plus 2 is 3. And now we use our algebra knowledge to solve for x. Finish the problem over here. So we get 579 equals 3x. Divide by 3 to undo the multiplication by 3. And let me grab a calculator. When you do 579 divided by 3, we get 193. Now we're not done because the original question is we need to know what the three integers are. We now just know that x is 193. We also need to know, remember, we labeled the second integer y and the third one z. But this is fairly simple because we said x was the smallest, followed by y, followed by z. So just like if x was 3, then y would have to be 4 and z would be 5. We know that y has to be 194 and z has to be 195. Just to triple check our answer, let's add 193, 194, and 195 up, and we should get 582. And if you do this in a calculator, you do. So there is your answer. Tricky problem. We take our variables and get an initial setup, and then we rewrite two of our variables using our knowledge that the numbers are consecutive. Okay, let's move down to the next one. Handicap H of a bowler whose average is A is found by using this formula. A bowler's final score for a game is the actual score. So their final score equals the actual score plus the bowler's handicap. Okay? We need to find the handicap of the bowler whose average score is 135. So the real way they determine the final score is they take the actual score plus the handicap. We are supposed to find the handicap whose average score is 135. So that second sentence, I initially underlined it, but it's actually not crazy important because it doesn't actually tell us how to solve the problem. What we want to focus on is the fact that the average is found by using this formula. Now we are told that we are supposed to specifically find the handicap of a bowler whose average is 135. Well, they tell me A is the average, and I know the average is 135, so I'm going to put 135 in there. And we are supposed to find the handicap, so H is the handicap, so I will now solve for H. We can simplify the parentheses first, or you could distribute if you would like. It is your preference. I'm going to simplify the parentheses. And I get 65 in the parentheses. 0.8 times 65 equals 52. And so I conclude that if I have an average score of 135, then the handicap for that bowler would be 52 based on the formula that is given to me that compares handicap and the average score. Moving on to number 14. I want a 94 exam average between my 4 exams, and I achieve those scores on the first 3. What do I need to get on the 4th? Well, the word average in math typically refers to the mean, okay? The mean being I add them all up and divide by however many there are. Now, what's interesting here is a lot of the time we're supposed to find the mean, but in this problem, they already give me the mean. I'm supposed to get an average score of 94. I'm told this 94 score is coming between my 4 exams, and I know the first 3 scores. Well, I know the mean is 94, and I know the way I find mean is I add all my numbers up and divide by however many there are. This is how we compute the arithmetic average. So we want the average to be 94. I'm told I'm taking 4 exams, and I know the scores for the first 3. But again, I didn't only take 3 exams, I took 4. So I can't just take the first 3 and divide them by 3. That'd be average of the first 3 exams. I want the average of my 4 exams to be 94. We're supposed to find what we need to get on the 4th exam. Well, we don't know that, so let's put a variable in there. And this would be our setup. Why? Because the average of these 4 exams, of which the 4th score we don't know, should come out to be 94. How do you find an average? Add all the 4 scores up, divide by however many exams I took. Little bit different because we're not finding the mean, we're finding an actual test score. But that's okay, we can start by combining our like terms. We can do 99 plus 89 plus 87, and I get 275 plus x divided by 4. Now, usually at this point, we would like to handle our subtraction or addition, then our division. But what's unique here is the entire right side is divided by 4. Okay? I can't just minus 275 because this is kind of like a 275 in disguise. What this says is this is really 275 divided by 4 and x divided by 4. Both are divided by 4. Well, if the entire side is divided by 4 and I want to undo division by 4, I multiply by 4. But what I do to one side, I must do to the other. 4 times 94 gives me 376. And on the right side, because everything was divided by 4 and I multiplied by 4, I'm just left with what was on the top of the fraction. I'm going to isolate the variable by subtracting 275, and I get x equals 101. Now, while this isn't necessarily possible, depending on the course and if they offer bonus points, we would go ahead and say that's what you would need. And the conclusion might be, hey, it's not possible to actually get that 94 average, but we were just told to find out what we would need. So the answer would be 101. Last question. A group of students measures the distance a toy car has traveled. So we have this table measuring times and distances. The students want to perform an analysis of the data set and consider removing the outlier. And then we want to know all that will be changed. Well, first things first, let's identify what the outlier is. An outlier is an extreme value, okay? It's a value that maybe was found incorrectly or just is very high or very low, depending on what you're measuring. So first things first, what is the outlier point? Well, the outlier point would be this guy, right here, right? We see as the time goes up, there are slight increases in distance, but here in the middle, we have this huge jump up to 13. That's a number that is extreme and would be considered the outlier, okay? So we want to know what will be changed if I remove the outlier point, okay? Well, what are they actually calculating? They're calculating the mean of the time and the distance, the median of the time of the distance, and the range of the time of the distance. Well, if we look at this, okay, how would we say find mean of the time? Well, I'd add all of these values up and divide by however many there are, in this case 6, and I would get some number. I do the same for the distance. How do I find the median? Order them least to greatest, cross them off till you get the middle value, okay? We know how to find all of these data values, but what's the question need us to do? We need to see what will change significantly if the outlier point is removed. So let's say I find the mean of the time, or let's do range, I would say. The range of the time would be calculated by doing 10 minus 5. This would give me a range of 5. But what happens if I remove the outlier point? Right, this was the outlier point. What happens if I remove it? Does the range of the time change significantly? Well, no, I'd still do 10 minus 5. Biggest minus smallest. And I would still get 5. So I would conclude that no, the range of the time did not change significantly. What if I do range of the distance? Well, again, simply do largest minus smallest. The range of the distance would be 13 minus 1, and I would get 12. But if we remove this outlier point, and then we recalculate range, now I'm only going to do 6.1 minus 1, and I would get 5.1. Did that change significantly? Yes, it did. By removing the outlier point, the range of the distance changed from 12 down to 5.1. So I would conclude that range of the distance does change significantly. You go through the other ones with the same process.